Hey, this is Joe. Today we're going to talk about factoring quadratics. More specifically, how do we factor quadratics when a is equal to 1? You will see quadratics in primarily 3 different forms within the classroom. You'll see them as expressions, you'll see them as equations, and you'll see them as functions. Luckily, each one of these forms are going to have their own set of directions usually to kind of give you information about how you should proceed with the problem. But for now, we're going to focus on quadratic expressions. This particular type of problem, where a is equal to 1, is kind of nice because we can suppress the coefficient in front of the x squared term. This really allows us to kind of explore what the relationship between b and c really are within this problem. So how many problems can they throw our way? If b and c are the only things that can change, well, let's classify it. On the left side, let's just let b be greater than 0 for these type of problems, and on the right side of our screen, we're going to let b be less than 0. And then we can break it down even more. On the top part of our screen, we're going to have c be greater than 0, and on the bottom side of our screen, we're going to let c be less than 0. And essentially, we get 4 different unique combinations of problems that they can throw our way whenever we let a equal 1. So let's talk about what the factored form looks like for each one of these quadrants. We'll start with talking about what does the factored form look like when b is greater than 0 and c is greater than 0. Well, we know where x is going to go because a is equal to 1, and that kind of simplifies things. But the nice thing about this is when everything is positive, both of our signs are going to be positive. So honestly, we get a lot of information by just knowing whether or not b or c is positive or negative. As you can see, I just filled in the rest of these in order to save some time. I recommend that you take a couple seconds here to pause the video and write some of these notes down. But here on YouTube, I wait for no one. So let's go further into one case and kind of actually look at what happens when we try to factor one of these expressions. We're going to work now specifically with the case where b is greater than 0 and c is greater than 0. One example that we're going to go through is what happens when b is 10 and c is 16. We already know that we're going to have 2 plus signs in this case in the middle of our binomials, but we don't really know anything about the numbers. So let's, for now, assume that our first number in the first binomial is n1, and our second number in the second binomial is n2. And we're going to try to kind of make sense of how we can get n1 and n2 to match up with the certain values of b and c for this particular problem. This brings us to everybody's favorite term, FOIL. Now you'll notice that here I have colors on FOIL, specifically to match the letters with the particular terms that they all are associated with. You'll see that F first is green and technically normally goes with the A term in front. Really, what that means is the first term in each binomial when multiplied together should equal my A term, which in this case is 1x squared. So 1x times 1x is equal to 1x squared, and we can move on to O. O deals with the outside terms of each of the binomials. In other words, in the first binomial, the term that's on the left side, and in the second binomial, the term that's on the right side. We would multiply those two together, and we get n2 times x. Now, we're going to put this off to the side because if you remember, I had O and I specifically colored blue. And when we move to inside, we're going to multiply the inside terms together. So in the first binomial, that's the second term, and in the second binomial, it's the first term, which is n1 and 1x in this case. And when I multiply those two together, I get n1x. Now, the reason O and I are both colored blue is because really they both have x to the 1 power in them. So in other words, we can add them together. And it turns out that in our quadratic expression, 10x matches the power of x that's associated with n1x and n2x. So what we end up getting is n1x plus n2x equals 10x here, because we're just trying to make sure that whatever we factor is going to be equivalent to the expression. Now, I can factor x out of the n1x and n2x terms, and I get left with n1 plus n2 times x. What do you notice? Well, I have x on both sides multiplied by some value. So I can divide by x and cancel it out, and really I'm left with n1 plus n2 equals 10. So in other words, the numbers that we have to place into our factored form have to add up to equal our b value, which is 10. Now we move on to last from FOIL. And those are essentially the second term in the first binomial and the second term in the second binomial. And when we multiply those two values together, we should get n1 times n2. But we have no x times these, which means that this is going to be equal to the constant within our expression. And if you recall, the constant in our expression is c. And so n1 times n2 must equal c, and so in this case, n1 times n2 equals 16. Now, if you think about it, we have n1 plus n2 equals 10, and we have n1 times n2 equals 16. So what we're trying to do is find two numbers that when we add them together they get 10, and when we multiply them together they get 16. So let's first work with two numbers that multiply together that get 16, or essentially the factors of 16. Well, we list those. There's 1 and 16, there's 2 and 8, and there's 4 and 4. Now, all these multiply together to get 16, but how many of them add up to get 10? Quickly, we see that 2 and 8 add up to get 10, right? They multiply together to get 16, they add up to get 10, so they must be our values for n1 and n2. This then gives us the factored form of the quadratic expression x squared plus 10x plus 16. Now, we can always check our answer by multiplying out this factored form by using FOIL, but I'll leave that to you as an exercise. Also, I plan on uploading a couple examples of this problem in separate videos to kind of extend the knowledge on this topic. So really, the whole point of this video was just to understand the process of factoring a quadratic expression whenever a equals 1 a little bit better, and really exploring the relationship between the b and the c value within the quadratic expression, equations, or functions. And hopefully, after you work more on these problems, you feel that your teacher is quite kind if they let a equal 1. Anyway, this is Joe, and thank you for spending some time with me.